Good morning, or afternoon, or evening, whatever time it happens to be for you. My name is Steve, and this is a terrible selfie. Hi. Oh, wow. I thought the first one was bad. Okay, so a little bit of information about me. I teach engineering classes for a living, and it probably looks this bad when I teach. That's part of the reason for these videos. I want to provide students something different, something to help along the way. Now, let's talk about you. For some reason, you have stumbled across this video series. Welcome. Who knows what brings you here? Maybe you're procrastinating. Maybe you're bored. Maybe your buddy said, "Hey, you gotta watch this dumb sciencey video with the weird engineering guy. His graphics are terrible." Yeah, I know. They're really bad. But maybe, just maybe, they'll help me get the point across. So, regardless what brings you here, welcome. I hope you are entertained.
Yay!
But above all, I hope you learned something.
Oh.
I know, that'd be terrible. For this particular video series, let's discuss a subject many engineers simply call thermo. That's thermodynamics for all the normal people out there. Thermo is the study of energy and how it flows and changes, and in general, makes your life awesome or terrible depending on your point of view. Yeah, it might sound kind of scary.
Dun, dun, dun.
And the truth is, most engineering students find it absolutely terrifying. But with a little effort, it gets better. The science of thermo was conceived during a time when people wanted to get the most out of their steam engines. Here's the basic idea. First, we're going to burn some type of fuel, something like coal or natural gas, or maybe we could use a nuclear reactor. The heat from this fuel source can be used to boil water. This, of course, generates steam, and that steam would like to expand. We can use the expanding steam to push or move parts of our engine. This motion, caused by the expanding steam pushing on parts of our engine, provides a type of energy called work, or power. If this steam engine is used in a factory or mill of some type, we can use the work from the steam engine to run our machinery and make products. Those products can then be used or sold for a profit.
Okay, so what you're really telling me is fire, something happens, and then profit.
You probably shouldn't go around saying that. It sounds like arson, which is illegal.
Okay, let's take a moment and introduce my imaginary students.
Hi.
Hello.
I want to thank you guys for being here today.
Thank you for having us here, sir.
Right. Well, suffice it to say, these guys will be helping us out with a discussion from time to time. Right now, the discussion would be fire, something happens, then profit. Now that's not inaccurate, but another really good point was made.
You're welcome.
Truth is, if we go around setting fires, we will probably land in jail, and I will assume make no profit. So, instead, let's say heat, something happens, and then profit. And the something which happens between heat and profit is called thermodynamics. Okay, so here's how this works. If you're going to study thermo, I need to make some assumptions about you. I'm going to assume that you have already studied basic calculus and physics prior to watching this set of videos. Now, if that's not you, don't worry. You're still going to learn something and hopefully have a few laughs along the way. But I'm going to assume concepts like derivatives, integrals, Newton's laws of motion, and conservation of momentum are not completely new to you. With your studies of basic physics, You probably learned that energy cannot be created nor destroyed. It can only change forms. This is actually what we call the first law of thermodynamics.
Actually, that is conservation of energy. We learned that in physics.
Well, part of me wants to say in an authoritarian voice, "You're wrong."
Oh, please do. That would make my heart happy.
But the truth is, the first law of thermo and the conservation of energy are essentially the same concept. The rate of energy entering a system decreased by the rate at which energy leaves that system is going to equal the change in the energy for the system with respect to time. Now, unless you've studied differential equations, this might look disturbing.
Ah! Really? The spider again?
I like the spider, sir.
Anyway, my goal for the next few videos is to show you how this equation can be applied to any situation you encounter. For example, let's talk about our steam engine. So far, we have mentioned heat in from the fire and work going out via the moving parts. Now, let's apply the first law to our engine. Now, don't worry about this differential equation right now. Think about it this way. In minus out equals change. The energy in minus the energy out is going to equal the change in energy. In the future, we are going to talk about the second law of thermodynamics. But all we need to know right now is the second law prevents a device, like our steam engine, from converting 100% of heat into work. So, we have energy in the form of heat entering the engine, and some of that energy leaves as work out. As you can see, the energy of our engine is changing, increasing to be exact. Now the question might arise, is this change a bad thing? To answer that, I have a demonstration. Warning, do not try this at home. We place a sealed container of water in a microwave oven. Now, the microwave will increase the energy of the air and water inside the container. At first, this is okay. In fact, this is often the desired effect of using a microwave. But with nowhere for the additional energy and pressure to go, we have a problem. We could face the very same problem with our steam engine if we continue to add more heat than the energy we remove. So we have to let the steam engine get rid of the heat that it couldn't convert to work. This satisfies the first law and keeps our engine intact for another episode. Hey, thanks for watching. If you liked it, give us a thumbs up, subscribe, and don't forget to follow us on Facebook. Stay tuned, there'll be more videos to come.